Okay, so for the domestic supply of electricity to homes, our homes electricity comes in through the main cable, and it consists. The name of the cables have a name now. What is the name? What wire is it? It's called a what wire? You all know? It's called a live wire. Ever heard before, right? And the neutral wire. Okay, there's actually a third wire called the earth. Okay, but earth is safety. Okay, you can actually do without the earth. Okay, so but for current flow, you must have a live wire and a neutral wire. Okay, so supply comes in a form of what? Alternating current. Alternating current. Okay, which comes from alternating voltages. Now, what is this alternating thing? Okay, alternating short form is AC. Okay, I think you all heard before AC supply, right? And it comes from alternating voltages. Okay, so what is this? Let me explain to you. So AC, there's two types of current, so to speak. There's DC, direct current supply. Okay, this is called direct current. And there is alternating current. Okay, so what is direct current? Direct current is our normal batteries, like that, as you all know. Like this is direct current. Direct current simply means here is positive, here negative, current flows this way. One way only. Current flows in one direction. That's it. Right? Okay, direct current. Okay, high to low potential, conventional flow of current. Now AC stands for alternating current. The symbol is not our usual battery. Our normal battery, we use torchlight, all these is not AC. AC is all these, our homes, all these supply, all these sockets, all these over here, all comes in AC for a certain reason, and that reason you will know when I come to a chapter of alternating current generator. Okay, so for now the symbol is like that. Symbol for AC supply is like that. What does this symbol? What looks like a what? Sine wave. Correct. It's a symbol of sine wave. So what does it mean? It means this. Okay, alternating current comes from alternating voltages, which has a graph like that, a sine wave. It goes from positive to negative, positive, negative, positive, negative, positive, negative, positive, negative. Okay, so alternate between a positive and negative. Meaning what? So at one cycle, you see this is positive. Here is positive, here is negative. Okay, half a cycle, then the current will flow. Okay, if this is my lamp, current will flow this way. Alright? Then it doesn't stay positive, negative. What happens? It will alternate. So the next moment, half a cycle later, what happens? This one positive become this side, and then the current will now flow this way. In both cases, the current, the lamp will work, no problem. Okay, the current will still be flowing through a lamp. It's just that the current is alternating. So half a cycle is going one way, the other half cycle is going the other way. Okay, so you say why so troublesome? Okay, later then you will know why, right? So this is the form we get our supply in. It's called AC. The graph, if you're asked to draw the graph, it looks like that, a sine wave with a positive and negative. Okay, whereas this one is a DC current power supply. You see it doesn't go negative all the way, just positive, like that, all the way positive. Okay, if I flip it about, you can get a negative, then it will be like that. Okay, all the way negative like this. Okay, so alternating current power supply, direct current power supply. Okay, the graph looks like that. Alright. Okay, so like what I just said, the live wire, the source of the live wire alternates between, okay, for Singapore is plus 240 volts and minus 240 volts. It alternates between these values. If you go to US, it is not 240. Or you go Taiwan, it's also not 240. The voltage supply is, anybody knows? You go Taiwan, you will know. Japan, all is 240. Korea also 240. Sentosa also 240. US is 110. Taiwan is also 110. So you got to, you cannot just buy a device. Okay, let's say me in Taiwan, specific for their country. I went Taiwan once, then I bought this very cheap speaker. I said, wow, so cheap, very good. I buy, bring back. I plug in. The moment I press power, it didn't explode. The light came on and then died. I said, what happened? Then I checked. I forgot to check. The power rating was what? 110 volts. Then Singapore is 240 volts. Gone case now. So I wasted my money. So whole thing cannot work. Okay? So
what if you bring 240 to 110? Can, right?
240, 110, it may not.
You bring the Singapore one to the Taiwan. Like you bring Singapore thing to the Taiwan.
Yeah, but it may not work properly. Not the voltage supply might be too little. Okay. So this one alternates between positive 240 and negative 40. Okay. Now we talk how the current flow. So when the live wire is at a positive potential, so this one is positive. Positive potential. Now you think common sense. Think neutral wire. What's the potential? Neutral. Guess what? Zero. So this is positive. This is 0 volts. Current flows from where? Which wire to which wire? Live to neutral. Yes. Okay, live to neutral. Now a lot of people assume wrongly this. Current always flow from live to neutral. Always live to neutral one because the name live what? Okay, but it's not always the case. No. The live wire is going to alternate to negative potential. So this one is going to change to become negative. This is a negative potential. This one neutral don't change, it's still 0. Now when it is like this, when the live wire becomes a negative potential, current flows from, what do you think? Neutral to live. Correct. Neutral to live. Why? Because now the neutral is at a higher potential. Okay, you all learn all this in electrostatic, make my life to explain this much easier. Okay, so you must not get the wrong idea to say that, current are always going from live to neutral. A lot of people think that because of the name. But actually it is also neutral to live also possible. Okay, because it's alternating between the two. Alright? So bear it in mind. Very common misconception. Okay. Then the next part here is quite commonsensical, I guess. Dangers of electricity. So we can do this. Okay. I will pause. Okay. Okay. First blank causes what? Electrocution, right? Okay. Damage, insulation. Okay. So you got to be careful if the wires are exposed. And you touch a wrong wire, you can get electrocuted. Okay. You touch a live wire, you can get electrocuted. If you touch a neutral wire, do you think you get electrocuted? No, right? Because the neutral wire is at what potential?
0.
And you are at 0, so it should be safe, right? But you touch a live is at a high or low potential, you can get electrocuted. Okay, Earth, the name Earth, what kind of potential? 0. So you touch Earth also fine, but you touch live, okay, that is the problem. Okay, that one big problem. Okay, now this one I actually explained, overheating of cables. So resistance wires of a conducting wire is inversely proportional. So thin wires have a high resistance, very high resistance, and produce a lot of heat, and should be used with appliances which require more low power. Okay, low power, which require low power. Okay, while thick wires are used for appliances with more power. Okay, so a low power means the current is small. So even your resistance high, okay, it's not so dangerous. It shouldn't generate too much heat. Okay. Okay, then the next one, this is also very common. We all love to do this at home. Plug in a lot of appliances into the same socket. And what happens? The appliances, so many, they will all draw a large what? Current. Okay, they will all draw a very large current. And then when they draw a large current, overheating becomes a problem. Okay, cables overheat and fires start. 70% of all fires in Singapore is because of electrical. Okay, you see all those, especially most common what? Read newspaper, what kind of fires? The PMD, right? Yeah, those are especially because of they didn't pass the safety check, all this, and the charging mechanism a problem of fire, the whole house catch fire. People upstairs, downstairs also all get affected. Okay. And then when I also told you this okay, the severity of electric shock depends on the what? Size of the current, not voltage, current. Voltage has a part to play, yes. High voltage generally will draw a very large current, okay, but it's the thing that current is the one that is dangerous. And you only need 50 milliamperes to get to die because of electricity. Okay? Seen this before at home, right? Circuit breaker, right? You know how to operate it? You ever have to operate it? Okay, usually not. Everything goes well, it's fine, okay? So all these, basically what's a circuit breaker for? Well, it's just to stop a large current getting through. Okay, if there's a large current getting through, the switch will flip. Okay, one of the circuit breaker switch will flip. Okay, so it will prevent a large surge. So what can cause a large surge? You may say, okay, lightning strike, all this, okay, possible. But also, if let's say you got a device at home. Okay, the problem with devices are especially high power devices like air cons like fridge all these they draw a lot of current. But if let's say there's some fault that developed in the fridge or the aircon, it suddenly cause a large surge. Okay, then it will cause one of these switches to trip, pump. Okay, it will switch down, and then your whole house no more electricity. Okay, if it wasn't for this, your fridge will draw a very large current unknown to you. When we are all sleeping, it draws a large current, and then after that, one fire come out. Okay, so circuit breakers are very essential, right? So when this switch goes down, okay, I ever tried before. Last time my house some problem. Don't know what's the problem. I push it down. It came down. I push it back up. Again, it tripped. Keep on tripping. So whole night no electricity. Then called the electrician. The electrician came and discovered that one of the multi-socket points, multi-socket these adapters spoiled. It was drawing a lot of current. So that's why it keep on tripping. Okay, so I remove it. Then everything okay already. Okay, so these are all very important safety devices. Okay, next one, power and lighting circuit. Okay, you look, this is called a ring circuit. This is how they connect sockets in our homes. Okay, there's a ring from the live wire, one ring like that. You notice there's a ring that goes round. Okay, and then from there they tap the live wire. Okay, they have all the sockets connecting to it. So it's various rings like this. Okay, that's why they call it ring circuit, right? This is a lighting circuit, and you all know already okay, the advantages of this at least the simple advantage is that one of them blow, what happen? The rest still can work, right? There's one clear advantage. And then the next clear advantage is also what's it? Same brightness, yes. In series circuit I also can get them to have the same brightness, but what? This one I require only 240, this will be 240, 240, 240, right? If they were all in series and each one of the lamps was 240, my supply would have been 240 times 3. Okay, so that's why parallel circuit for lights are required. Okay, come. Okay, they ever ask definition of neutral wire? Nobody know what to write. Neutral wire, and people just say for current to flow. What am I going to write? Okay, so you are supposed to write like that. Is at the potential of what? What did I say? 0 volts, yes. and allows current to flow between the live and neutral. You see, I also say the word between. I didn't say from, between, because you know it's going to alternate. Okay? Then a function of live wire is potential what?
Varies, alternate.
Alternates. Okay, we use the word alternates between, if it's Singapore, plus minus 240 volts. Okay, and then allows current to flow between a live and neutral wire. Okay. Okay, now we come to the one of the most safety devices you need, and they often ask this in questions. Function of a fuse. First of all, the symbol of fuse is like that. Okay, I think I drew for you already previously. Okay, so it looks like this. This is a fuse. So what is a fuse for? Okay, you will say fuse blow okay, too much current will blow okay, yes. How to explain properly? You write this down. A fuse is a safety device which is placed on the which wire? Which wire you think? Live. There's a reason why it's on a live, which I will tell you later. So when current exceeds the fuse rating, the fuse will blow, melt, okay, and the circuit will become open. Okay. All right. Okay. Now fuses come in certain ratings. So how you determine the rating is like that. Okay. So if your current needle is 0.5 amperes, let's say your device not very powerful, then your fuse you use is the next higher integer. You say 1 ampere. Okay. Don't say 0.6 1 Then if it's 3.3 ampere, your fuse rating is how much? 4. Here is 4 amperes. Okay. Okay. Now, how does a fuse work? So you put a fuse. Let's say you have a fuse like that. Put a fuse like this. Okay. Your fuse, your switch always on the live wire. Okay. So you have a switch as well, like this. And then you connect, let's say, to your computer. Okay, your brother must be very busy playing games, right?
No. No.
Yeah, he's so free, right?
Yeah.
Okay, so his computer, because your brother N-level result very good, your father very kind, give him $20,000 computer. Then you buy a 20-cent fuse. Then after that, the computer 240 volts, let's just say it's 2 amperes okay. Then you put in a fuse, you put in a fuse 1 ampere, and you close the switch, what will happen? What blows? The fuse blow, right? The fuse can only take 1 ampere, so straight away this going to draw 2, you will blow the fuse will blow, melt. So every time you start there, fuse blow, cannot play. Very frustrating, because forgot the physics lesson already. So he changed, got frustrated. Don't want, one cannot. So fed up, use 10 ampere. Close the switch, what will happen? Can work. Will it blow? No, it doesn't blow. Okay, actually everything will not work normally, right? As per normal. Okay, it is actually no problem affecting the computer's function, right? Because it needs 2, so it draw 2, the fuse 10 ampere, you just let it go through, no problem. Okay? The only problem come when what? When suddenly got some fault develop, suddenly let's say 9 ampere come. Will the fuse melt?
No.
It will go straight through the fuse will say, go through me, no problem. You come here and then what happen? You will explode. You will blow. So the computer has managed to protect the fuse. Right, the $20,000 computer protects the 20-cent fuse. Right, the other way around. So you cannot have a fuse that's too high. Okay? So what you need is if 2, then this will be what? What did I say? 3. This will be 3. So you choose a fuse rating of 3 will do. Okay? Just choose a fuse rating of 3. Okay, so now that's the fuse rating. Now why can't I put my fuse on a neutral wire? If I put my fuse on a neutral wire like this, first of all, does it affect my computer function? No. It still works as per normal. I close the switch, open the switch, no problem. Okay? Okay, so what is the problem? So why is it my fuse? Okay, for the matter, so switch also must be placed on the live wire is this. So if let's say the fuse blow, okay, so one day the fuse blow. Okay? Fuse blow, computer obviously stop working. Jeremiah getting sleepy and hungry. The Oreo taking effect. Okay? Now the computer, once this blow like that, is there current flowing through?
Yeah.
No, right? Open circuit, right? Cannot already. Here, plus minus 240 volts. Here, 0 volts. So our natural instinct when something doesn't work, we think, oh, no current, that means safe lah. So the danger is, if I go and open this up and I go and meddle around, try to fix anything, and I come into contact, let's say with a live wire, what will happen to me? I will die. I'll get a very bad electric shock, may even die, right? Why? Because it is still, the term is to use is this, the appliance is still considered live. It's still at a high potential. Right? The voltage supply is not zero, no. So I can get electric shock. Okay? So that's why everything must be on the live wire. So that when this blow, and when the switch or when the switch is open, like that, the switch is open. Once the switch open, Peng Hong, the potential of the appliance is how much? Zero. So I touch anything, I touch live wire, touch whatever I want to touch inside and fix, it's not going to electrocute me. Okay? Got it? No? Okay, so important to know why everything is on a live wire and how to explain as well. Right? So how to explain as well is here. Okay? Fuses and switches must always be connected along the live wire. Okay? Okay, so this is how you explain. So when the switch is off or the fuse is blown, one can safely touch the exposed live wire or do any repairs as the appliance is disconnected from the high voltage, no longer at plus minus 240 volts, and then no longer live. Okay, so if you put the switch and the fuse on the neutral wire instead, what happens? The fuse blow, the appliance become what we call live. So I'll use this word very often later, you will see. And then it's still at a very high voltage, and then you touch anything, okay, the live wire especially, you can get electric shock. Okay, so this is a good explanation to know why everything must be on a live wire, right? As in the switch and the fuse. Okay, now, when does the fuse blow? The fuse blow when there's a large surge of current. Okay, what we call a short circuit. I actually haven't told you all much of short circuit. Now look, this, if I got two resistors like that, okay, let's say both are same resistance. Jeremiah, if you are awake, tell me the current will be what? In the two resistors?
Before.
What, before or after? When the current comes here, what happens? Split equally?
Yeah.
Yes.
Yeah.
Right? Equally, right? So this one be equal to this one, right? Okay, let's say this one is very, very, let's say the resistor I change, become very small, 1 ohm. Which one will draw more current? 1, right? Okay, now, if I connect one wire like that, one wire like this, where will the current go? It will go through this. Nothing will go through here, right? They will bypass. Everything will go through here. Okay? Because there's no more resistance. The resistance, So all the current will be here, and the current, the total current will be now very large. No? Why? Because these two are no longer active. Okay, this is what we call a short circuit. Okay, so the current becomes very large. So any situation like this will cause a very large surge of current. Live wire touch neutral, meaning what? You see, this appliance here has resistance. But if let's say my wire, some reason the live touch a neutral, it bypass all this resistance, it becomes a situation like this, the surge of current will be very high. Then it will cause a fuse to burst. Okay? So similarly, you touch an earth wire, touch a metal casing, metal very good conductor, so it will cause a large surge of current. Everything, okay, the current goes up, fuse will blow. Okay? So all these are situations fuse will blow. Surprisingly, many people think when you touch a live wire, the fuse will blow. Actually, it won't, because you have resistance. You have resistance. Okay? You have resistance. You will draw a certain amount of current, but the current is not big enough to blow the fuse. Okay? So it doesn't blow, no? Right? Even when you touch a live wire, neutral or in a sense, nothing happens. Okay? So the switch on the other, okay, so that is the fuse. Okay, this video very long already. I think they cannot tahan. 26 minutes already. Okay, so the function of the fuse, function of the switch is to what? Open or close, yeah. Open or close. And it also must be connected to or placed on the live. Always on the live.